emergent. And in fact, in our discussion of the table, we can use the same language. So the standard model is the physical qubits, and the phonons are the logical qubits.
Maybe that's the problem I never got. Who knows?
Or we could say the standard model is the fundamental description, and the phonons are the effective description. And so quantum error correction, I would say,
Maybe I never switched it back on, right? Maybe when I like at that point, like when I switched it off on the weekend, I didn't switch it back on a Monday.
So it's almost an accident, right, that it was first really formulated in the context of quantum computing. I would say what it really is a language for talking about emergence, for talking about how the effective degrees of freedom are embedded mathematically into the fundamental degrees of freedom. And once you have that idea, then you can start seeing a lot of parallels between all these different problems where you have to solve that kind of problem.
And so when you port that mathematics over, and now we're getting to work, in the last 10 years, I guess, is when you started to do this, how far does it take you toward understanding the application that drove you in the first place, the information paradox?
Right. The question is, once you have this idea that you have a map from the logical to the fundamental degrees of freedom, the question is, can you use that to address Hawking's paradox? And so I would say we've gotten pretty far. We haven't gotten all the way in the sense that I still don't have a full theory of quantum gravity where I can reproduce all the known features of black holes, in 3+1 dimensions. But I have cartoon theories where I can reproduce all the essential features of Hawking's paradox.
Right. So what he's trying to say is that degrees of freedom, okay, is built off, like as I said, like there's a 3D space, right? Space, and there's a 2D space, right? Now within these spaces, within this space here, anti-de Sitter space, right? ADS. Okay, or DS, whatever, right? That this point between, for example, Alice and Bob of entry to, let's just say, beyond the horizon of the black hole A, for this, we'll call this system Alice, right? And then from Bob, the exit system will say, or we can say Alice and Bob is, Alice is the person outside of the black hole, and Bob is the person falling into the black hole, right? Now, during this process, there is a measurement. Now, degree of freedom, okay, expresses that within a 3D space, we have up, down, left, and right, which is 6 different possible independent systems, right? And within that, then, obviously, there are different independent systems based on geometry. It's the best way that I summarized it quickly to explain it. Now, if we obviously have limited degrees of freedom, then the determination of that degree of freedom must, in some regard, remain constant, right? So, like, how is that constant?